The march of scientific discovery continues, and once again this month is abundant with new information. Here are 7 noteworthy scientific discoveries that occurred in October of 2023. Hello everyone, welcome back to Zeey. Subscribe to our channel and ring the bell to receive a recent and mind-boggling information. Number 1. The star with 2 faces. Stars tend to be relatively homogeneous, as their spectra reveal a composition that varies little depending on which aspect of the star you are observing. A recent discovery has demonstrated, however, that this is not necessarily true for white dwarfs. Researchers at the Zwicky Transient Facility in California discovered that the star was oddly differentiated, earning it the nickname Janus after the Roman deity with 2 faces. The star is composed of hydrogen on one side and helium on the other. This white dwarf, located 1,300 light-years away, matches a model of white dwarfs in which they can transition between hydrogen and helium. It was captured in the act. This involves magnetic fields, and it is possible that this star's magnetic field is asymmetrical, causing the differentiation. This would produce the effect by disrupting the star's convection in an uneven manner, although many details of this are still unknown. Strangely, you would be able to see this if you were in this star system, as the 2 halves of the star would display a 15% luminosity difference, although the star would be much brighter than the sun overall due to its higher temperature. A most peculiar star indeed. Number 2. Predicting earthquakes with the GPS system. Seismic forecasting has been notoriously problematic. Once upon a time, it was believed that it would be extremely unlikely for us to ever be able to predict earthquakes, as they are chaotic and unpredictable. However, we now know that certain areas are prone to earthquakes, and the longer we wait, the greater the likelihood that one will occur. In recent decades, however, there have been indications that earthquakes may be preceded by events that offer the possibility of predicting them in advance. And this may now be possible due to the GPS system. We'll need a system that is 100 times more sensitive than what we have now, but recent studies have shown that GPS systems can detect gradual, accelerating slips in land movement and provide up to 2 hours of warning before an earthquake. The problem is that they used a massive aggregate data set, and the resolution is not yet sufficient to predict individual earthquakes. However, as technology advances, it may become possible to predict at least some earthquakes and provide residents with advance warning. Number 3. Nerve clusters and consciousness. Consciousness is one of the greatest mysteries of the brain and, indeed, of the universe. We still don't know how it emerges, but we do know that we can fall asleep, be struck out, and sustain brain injuries that impede its operation, however that occurs. But we do know that consciousness appears to have 2 distinct but interdependent components: consciousness and waking up. Researchers at Harvard have recently mapped clusters of nerve cells located in areas of the brains of animal and human cadavers and discovered that they do connect, beginning in near the brain stem in clusters previously associated with wakefulness, and how they connect with clusters in the central brain, and then to clusters in the outbrain, which is associated with consciousness. Using a sample of living humans to advance their research, they were able to demonstrate how electrical signals travel and interact from each of these clusters. This may provide insight into the nature of consciousness, although it is still early in the game. In the near future, however, it may help physicians better comprehend a variety of psychiatric disorders, neurological diseases, and even coma following surgery or injury. Number 4. Flies apparently like to play. Many individuals dislike fruit flies, especially when they invade their homes. However, they are also very fascinating creatures in their own right. What has always been unclear about the insect world is what behaviors they share with the rest of complex life on Earth, and believe me, insects are well represented in this category. Play is an interesting topic. We observe amusing behavior in a vast array of species on this planet. It is common to observe canines, cats, gorillas, and a variety of other mammals engaging in play. We certainly do, from infancy to merely tinkering with something frivolous like a Rubik's Cube, which are the bane of my existence because I can never solve them. But the most pressing concern was whether or not insects also play. Indeed, it turns out. The results of research on bumblebees indicate that they enjoy rolling wooden spheres for amusement. One wonders how prevalent this is and whether or not spiders partake. Now, however, fruit flies are the ones who enjoy riding on rotating carousels. The University of Leipzig in Germany conducted a series of experiments involving food and rotating and stationary carousels. Compared to flies that landed on stationary carousels, flies that landed on rotating carousels spent significantly more time sitting on it while it rotated. You'd think that if it was unpleasant to sit on a spinning carousel, the flies would avoid landing on it altogether, but they didn't. Instead, many of them flocked to it and seemed to enjoy it, while others avoided it. Perhaps insect motion sickness exists. Number 5. Europa is leaking carbon dioxide. Europa is without doubt one of the most intriguing objects in the solar system. A very ancient object dating back to the earliest days of the solar system that appears to have harbored a liquid water ocean beneath its icy surface for a very long time and may have supported life. We simply do not have enough information to determine if there isn't a fatal aspect of the subsurface ocean that prevents it from having the conditions for life to develop. But indications that it does are accumulating, and a particularly significant one was recently discovered. In essence, the ocean of Europa emits carbon dioxide into space. This is a recent discovery made by the James Webb Space Telescope. Observations have shown that CO2 is escaping into space, particularly from a region called Terra Regio, which exhibits a shattered, chaotic landscape with fissures that may lead directly to the ocean below. This area of Europa's surface is also quite young, dating back only a few million years, indicating that the moon's surface has only lately interacted with the ocean below. However, other so-called regions of chaos terrain also exhibited elevated carbon dioxide levels, making it less likely that the source was meteorites rather than the subsurface ocean. However, this does not indicate the presence of life in Europa's ocean, rather it indicates the presence of carbon, which is essential for life. It contains the essential element for carbon-based biochemistry. However, it does fulfill a requirement and strengthens the case for a deeper search for life in the moon's oceans. Number 6. Updates on the Dimorphos collision. The impact of NASA's DART mission into the asteroid Dimorphos to see if we could deflect it, or in this instance slow the small asteroid's orbit of its larger parent asteroid Didymos, was one of the highlights of the year 2022. This was a proof-of-concept experiment because the fundamental physics of impacting objects is quite predictable, despite the possibility of anomalies if you don't know every factor. In this instance, it was successful, decreasing the orbital period of Dimorphos by 33 minutes. Intriguingly, this is another instance in which citizen science has advanced our comprehension of what transpired, and it has actually created a mystery. This was accomplished by a high school teacher and students equipped with a 0.7-meter telescope capable of distinguishing between the two asteroids. After the initial collision, they discovered that the orbit of Dimorphos has since shifted 1 minute to 34 minutes. This is genuinely quite large. There is evidence that Dimorphos was previously tidally locked to Didymos, and that our impact upset the apple cart and threw it into an irregular condition, causing the orbit to slow down. The impact may have caused the asteroid to begin librating or rocking like our moon does, but in this case it may have cascaded and caused Dimorphos to go chaotic and evolve into outright tumbling, with the gravitational forces being disturbed by this being responsible for the additional minute of slowdown. But a more likely explanation is that massive boulders were thrown into the air by the impact, and their subsequent fall altered the orbit. There was a plateau shortly after the impact, which would be consistent with material falling back onto the surface of Dimorphos if more recent research supports this theory. As the ESA Hera mission arrives at Dimorphos in 2026 to observe the aftermath, this will eventually be better understood and the question will likely be put to bed. Nonetheless, this will be significant as this is our first real step toward asteroid deflection, which will presumably render humanity immune to asteroid extinction events in the future. Number 7. The very real underwater effects of volcanoes has gotten worse. Volcanoes are without doubt among the most destructive forces on Earth. Populated areas near volcanoes are always in peril, and they can devastate areas for many years, as was the case with the explosive eruption of Mount St. Helens on May 18, 1980, which I witnessed as a young child from across the Columbia River in Oregon. It is something I will never forget, and the devastating effects on the surrounding forest and lakes are evident today. Volcanoes remain a formidable threat in seismically unstable regions. However, destruction on a human magnitude is not limited to the Earth's surface, it also affects the ocean floor. In 2022, the eruption of the Hunga Hapai volcano in Tonga revealed a previously unknown form of enormous underwater volcanic flow. Volcanoes can generate pyroclastic flows, which are massive, fast-moving flows of ash and gas that descend mountain slopes and obliterate everything in their path. These extremely heated currents were responsible for the destruction of Herculaneum during the eruption of Mount Vesuvius in 79 AD. This phenomenon is characterized by a pyroclastic density current, which can presumably transfer to the ocean when a volcanic flow of this type strikes it, thereby generating an underwater density current. It was known that this phenomenon was possible, but not on the magnitude of the eruption of the Tonga volcano, which is the largest volcanic eruption of the 21st century. How this was discovered and mapped out was straightforward. It destroyed and severed hundreds of kilometers of telecommunications lines and caused significant alterations to the exposed seafloor. When a volcano erupts, the ocean does not always provide protection. Alright guys, this video ends here. Thanks for your attention. If you find this information valuable, give it a thumbs up and subscribe to the channel. We'll provide you with regular, in-depth explorations of the fascinating, strange and unknown aspects of the universe in which we reside.